First of all, good morning, everyone, and welcome to the second session of the RIAI IGBC Design for Performance training series. So my name is Elizabeth O'Brien, and I'm back to chair this morning's session. We had it last week as well. I'm delighted to be with you today as we explore how to integrate performance into the work stages of the project. So that's what we're going to be discussing today. We're four great speakers, and I'll be introducing you to you shortly for those. So as you see, today's session is titled Embedding Performance in Design, Principles in Action. And we'll be hearing from leading professionals on practical strategies to set targets, track performance, and verify the results. So we'll begin with a detailed presentation. Thank you, Ginlin. So this is a design for performance project and framework. And as you see, the introduction, which will be myself, I try and keep it as brief as possible, and then we can start moving on. So our first presentation is Design for Performance Framework, Indicators and Project Work Stages by Sinéad Hughes from IGBC. Early Adoption and Performance-Driven Briefing, and that's be from Archie O'Donnell from Cosmos. And then we'll go into an interactive poll. Hopefully you'll participate with that. We had great participation last week. And then we move to the Q&A session. So depending on the time, we'll try and give 15 to 20 minutes. Then we'll have a comfort break of 15 minutes, if that's okay, everyone, so you can stretch your legs, etc., and grab yourself another cup of tea, etc. Then in the afternoon, we'll be tracking and delivering on design intent from John Casey from Cora. And the final presentation is from Edel Collins from OPW, Making Performance Visible, Closing the Loop. And be using case studies in many of these presentations. Then we'll wrap up with the Q&A for John and Edel, have the poll results for you, and then closing remarks. And we'll pop up the agenda, I think, for the last session, which will be next Friday. So that's the running order. So I think now we're at 258 people. I think we'll continue, and I'm going to introduce Sinead. So Sinead Hughes, she's Irish, works at the Irish Architects. She works at the IGBC, beg pardon, Sinead, but she has very active with the Irish Architects. So Sinead is an RIA registered architect with 26 years of experience and is accredited in the conservation of Grade 3. She is a current second Vice President of the RIAI and represents Ireland on the Architects Council of Europe Women in Architecture Task Force. So IGBC, she leads many initiatives, including ENACT and the Building Renovation Passport pilot. Sinead also worked on the BUSY 2030 Skills Roadmap for Climate Action, a key contributor to Design for Performance Framework, and she brings deep expertise in sustainable construction, retrofitting, and sector-wide upskilling. So Sinead, without further ado, I'm going to let you take over. Thanks, Sinead.
Perfect, thank you. So hello again, delighted to be here again. I did a brief overview at the session last week, so just going to delve into a little bit more detail. As you can tell, the project is called Design for Performance, SEAI funded, the RAI, Royal Institute of Architects of Ireland, in conjunction with the Irish Green Building Council. So the name Design for Performance is of critical importance here. Essentially, we're trying to promote a collaborative cultural change to move beyond designing for compliance, looking at designing for lifespan, essentially focusing on performance of projects. So just at a very high level, the suggested goal here is that we start with end targets for projects in terms of performance, because as we know, the most impactful decisions can be made at the very earliest stages. By way of context, the RAI have obviously a suite over the years, a suite of documents informing members in industry, beginning with the initial RAI sustainability policy, moving towards the design pathways, and then most critically, the climate challenge, which essentially was a call to action to members in industry to focus on specific indicators and how to reduce our collective emissions in light of broader national and European and international targets in terms of climate change. And then there was a suite of documents accompanying that in terms of advice notes. So essentially, the Design for Performance framework is a follow-on from that initial climate challenge. Again, just to highlight that that was a 2030 climate challenge. 2030 is not that far away, and really we need to be moving beyond and focusing on our 2050 targets ultimately. So the actual climate challenge, for those who are not familiar with, is focused on 4 indicators, and the challenge calling industry to introduce life cycle analysis by setting targets for these 4 indicators based on comparable typologies. And we can come to that in a second. So the 4 indicators were embodied carbon, operational energy, water use, and health and well-being targets. And how that was addressed in the challenge was really focusing on domestic buildings, non-domestic buildings, and schools, with specific metrics around each of those indicators to promote an action and a target for designers and contractors and clients, essentially collectively, to aim towards, if not better. So what is the Design for Performance framework? Our purpose of our conversation here today. Essentially, we have focused on these 4 indicators and looked at them individually in more detail, looking beyond compliance, not only compliance, but looking at actual energy building performance, I should say, the actual building performance, and how to target that end goal. Just by illustration, looking at a diagram here from SIBSE, looking at essentially part in this particular example, part L compliance modeling versus performance modeling, but critically looking at the actual energy usage and differentiating between regulated and unregulated. So it's really that collectively within industry, we really are looking at that broader, the actual situation and performance of our buildings and our properties. In addition, within the design performance framework, we don't want to be reinventing the wheel. So in looking at the EU levels framework, we've focused in again on these 4 indicators. And for those who are not familiar, I would urge you to become more familiar with this. It's an available tool. It's essentially a European-wide approach, to help us assess sustainability performance of buildings through their life cycle. And at a simple level, there are 3 levels in terms of initial statements surrounding indicators versus more detailed reporting as a project develops, and then the measured as built and in use, the actual performance. So our design for performance framework really is a parallel suite of information within the context of the EU levels framework. So by way of introduction, I really urge you to become more familiar with the Irish Green Building Council. As Director of Innovation there, we are working on a broad amount of research and informative workshops and focus groups and publications and policy documents regarding to promote a more sustainable built environment. So some specific documents to highlight is a building zero carbon roadmap that we published, again indicating what can be done by whom and when in order to reach our 2030, 2050 targets. Just recently, we published Building a Circular Ireland roadmap, again, similarly looking at the whole area of circular economy within the built environment. And we looked at our issue of skills. Essentially, we really need to be more clever. It cannot be a business as usual model for delivery, because we have really, really ambitious climate change targets, and we don't have enough people with the correct skills in order to do this. So really how we collectively can move forward in a positive way and see all of this as an opportunity. Another piece of research that we were involved in, you may or may not be familiar, and this really is just illustrative, just to give a context to some of the metrics that are in the climate challenge. This was a research project we looked at analysing 50 buildings that were essentially they are completed projects, and looking to see what is the embodied carbon. These are just embodied carbon metrics. I'll just draw your attention to the red box there, looking at 826 kilograms of carbon equivalent per meter squared in the average typology building for new build, and just looking at the horizontal red line of where that sits within the 750 figure, which is in the REI Climate Challenge. Again, that is a 2030 figure. It's just an indicative target, but this starts to just set properties and buildings and typologies in context. Again, not getting into the huge amount of detail in that today, but that's just by illustrative to assist kind of making the information more accessible. So what actually is the framework that we're talking about today, the design for performance framework? And it's very simple. It's 3 separate documents. It's a work stage overlay. In other words, the stages of a construction project, whether it's new build, renovation, small scale, large scale, public sector, private sector. It's really just an overview of work stages. It's a guidance document, which is essentially a PDF document to assist you in kind of delving deeper into the issues. And then it's a dynamic tracker, which is a live Excel for you to adapt according to your own project. So we'll just delve a little deeper into those. Again, we've taken each of these 3 documents, looked at the 4 indicators, and because of time constraints today, we'll just have a look at one of those indicators, which is embodied carbon. So in terms of the work stages, we have taken our lead from another RAI document, which I would encourage you to look at, which is the DFMA report, essentially looking for design, manufacture, and assembly in the context of modern methods of construction and efficiencies and prefabrication. So we've looked at the stages, and I'll just draw your attention there to that post-occupancy evaluation in use stage. So we'll delve a little deeper now. Again, we're very aware, this is just really for illustrative purposes of the varying different types of contracts, numbers of stages, outputs. Essentially, the framework is just, we are focusing on the 8 stages within the RAI contract, but cognizant that there are other work stages, but there is a parallel in terms of the topics. Excuse me. So taking a more detailed look at these stages, essentially looking at the issue of post-occupancy and in use, I would strongly encourage you to revert back to the webinar sessions we had last week and Judith Kimpion's presentation on the performance gap and the really significant challenges around that, and some practical examples that Judith presented to us last week, essentially in that context of designing for lifespan. And then in looking in much more detail at this work stage, that we start to learn lessons, we start to learn from the metrics, we start to track our data, and then we adapt those learnings and that knowledge into our next projects. So again, very high level illustrative today, but Archie will follow me now and speak about setting targets, and John will then follow looking at the performance tracking throughout the lifespan of a design, development and delivery project. And then Edel from OPW will actually look at more detail at that post-occupancy layer and timing and information, verification, monitoring, improving and feedback into subsequent projects. So what is the overlay? Again, just sticking with embodied carbon. So essentially in the document, it is a high level sort of one page glance at the topic of embodied carbon and looking at the issues that I would suggest should, could be addressed, looking at a specific task and then the responsibility around this. So again, you may have 3 consultants on a project, you may have 13 consultants on a project. So it's really to tailor at a project specific level what could be done. And really these are just prompts for to be considered at the various work stages. And again, I'll draw your attention to that post-completion, post-occupancy evaluation stage, which we're flagging here. And again, if you revert back to our presentations last week, issues around how that might be adapted within a building contract. In some cases, from a liability perspective, it may even be a separate contract. And I know the RAI, internally, it's reviewing current work stages and contracts of how projects need to capture this additional work, essentially. So we're very well aware of that. But today is really about promoting a culture of collaboration and performance assessment at a broader level. And the detail really needs to be on a project by project basis. So again, sticking with embodied carbon throughout the work stage, essentially, and to quote Judith Kimpian again, our colleague who presented from last week, who's a representative from the Architects Council of Europe, looking at this idea of a golden thread through a project, that you set initial goals and targets, and then as you move through the design development stage, you reduce those carbon hotspots. Again, looking at when more detailed information is being assessed, perhaps there's value engineering exercises, but what are the carbon impacts of those decisions? And then again, throughout the completion stages and then as built, to really see how the carbon, in this case, let's say whole life carbon, is assessed in relation to those original targets that were set at the early stages. So the guidance, essentially, the guidance is a Word document or a PDF. And really at an initial stage, I would strongly encourage you to read the introduction, section 1, introduction, section 2, the climate targets. Again, we're just focusing on those 4 indicators, but I will draw your attention to the life cycle global warming potential, life cycle GWP. Again, stumbling with the language myself. Again, I would urge you to revert back to Gary O'Sullivan from SEAI, did a very detailed presentation last week on that specific topic and legislation around how it will be mandated for tracking the metrics around all of these topics, essentially whole life carbon. So again, the guidance document is to sort of break down on a topic by topic basis the requirements for each of these elements. And indeed, in due course, as industry evolves, we would be further adding circularity metrics, social value metrics, biodiversity issues. So this is not this really is a dynamic and working conversation and process around industry. So really there's just so much to do and essentially so many opportunities. Not to see this as additional work, it really is an opportunity for resource efficiency and tracking deliverabilities as we work through our projects. So within the guidance, embodied carbon again, just as an example, we have highlighted what are the key principles, the responsibility around that within the project, who, what, why, when, and then looking at each work stage, highlighting the task, suggested resources, because maybe for a lot of people this is becoming it's a new topic, it's a new task, and deliverables on that topic at each stage that indeed can then tap into and feed into broader deliverables under contractual requirements at whatever project contract that you're engaged with. So the key principles, by way of example, just highlighting what is important about embodied carbon, and just that's like ... again, suggesting you to read the chapter on that. Looking at each work stage, we just have a kind of a high level introduction to the topic within each work stage, to then delve deeper into, as I say, the task, the responsibility, and the support. Again, we've really put a huge amount of names assigned to this, but again, we are absolutely aware that not all of these consultants will be on a project, and maybe it's the same person wearing many hats. So again, just by way of illustration, there's a parallel, and there's obviously multiple parties engaging in construction projects and delivery these days. So it's just to kind of have it on a project specific, case by case basis, whatever is appropriate for your project. As this suggests, there are a number of tools. Again, it's such a complex area. There's so much advice and guidance, and really, we've just indicated a selection of resources for industry to refer to. But again, this is continually evolving, and just to become more aware of the language and the targets and the metrics and the legislation around all of the various issues. And then critically, I suppose it's an awareness around deliverables. This may or may not be an internal document. It may be something that you have to deliver as part of your client agreement, but really it's just prompting an awareness of, have we closed out the topic at that particular stage, and are we aware of what we're doing and bringing it to the next stage? So then the third document within the suite is a tracker, a dynamic tracker. Essentially, it's a live Excel. So almost similar to a health and safety register. You might adapt this to suit your own practice, your own types of projects. Really, we're really just encouraging that it's a process for assessing and monitoring as a project develops in terms of those four indicators that we've highlighted: the embodied carbon, operational, indoor air quality, and water. So what is the tracker? Essentially, at its basic, it's an Excel, looking at the action, looking at who is responsible. So there is an owner. There's obviously, we really are promoting collaboration, but ultimately someone needs to sort of be responsible to corral all of the parties associated, looking at the deliverables, critically the risks associated with some of the items. So it's really just a monitoring, and this might be as much as a prompt around design team meetings or client meetings or whatever that might be. We're just suggesting that you take this and adapt it to suit your own purposes. And just to acknowledge your credit here, our tracker is based on the Monoro decarbonisation platform, which is essentially is an open source resource that was developed by Grimshaw Architects with other parties, including World Green Building Council. So again, that we're sort of collaborating, sharing resources, and not reinventing the wheel. So just to delve a little deeper, I appreciate this is a more detailed slide, but it's really looking at the topics of embodied carbon, operational. In this case, we've actually grouped them together under each work stage. So you would track each item. Again, you may tailor this, you may make it even larger, you may edit it down. And it's really just a suggestion for you to take and amend to whatever suits your own purposes. In addition, we also have within the tracker the EU level statement, which is at a higher level. Let's say in this example presented, it's at level 1, which is really the conceptual early stages. And again, there's more detailed objectives and requirements as you develop through your project, and then the as-built. So again, this might be an easier table to monitor and track. But again, we're just presenting this as information for you to take as you wish. And then just highlighting, moving to water, same again, that there is a tracker there for the various items at each stage. And again, the levels statement, just looking at some of the issues to really prompt an awareness at those early stages in terms of those final targets and metrics that we're trying to achieve at the end of a project. So what are the benefits of using design for performance? Essentially, as stated at the outset, it's about target setting as early as possible and then working through that through the work stages. It's focusing on performance evaluation rather than, and I say this word, just looking at compliance. It's looking at the full life cycle, moving towards a really ultimately a more circular approach in the long run in terms of how we look at our built environment, confirming decisions that are made and the impacts, and verification. That is a critical thing. It's not just to say, okay, done and dusted. It's actually to test, to monitor, verify, and continually improve performance of our built environment. Key message today, and we have multiple other colleagues during this suite of presentations over 3 Fridays, it's really about a culture of collaboration. We really need to work together, especially from those early stages. And we must move beyond design intentions to evidence-based performance. That's a critical point. And we all have a responsibility and a role in this. Where to start? It's a very busy area. There is a lot of information. We would suggest start simple, pick one project, maybe just test it out, do some upskilling, get a little bit more familiar with the metrics, the processes according to your own practices and your projects. Collaborate and learn from project to project in terms of tracking the metrics and bring those learnings into the next project. So I'll leave it there, Liz. I hope that was okay, and many thanks everyone for your time today in joining our sessions.
So, without further ado, I'm going to move on to Archie. Archie O'Donnell from Cosmos. Quick introduction. Archie is a sustainability and carbon specialist with 25 years of experience in the built environment. He specializes in the evaluation of whole life carbon to create decarbonisation roadmaps for buildings and portfolios. Archie undertakes materiality assessments to determine and assess risks of stranding and obsolescence. So, through science-based targets to 2030 goal settings. He works with costs consultants and quantity surveyors to identify practical solutions for achieving carbon neutrality and climate resilience. So, developing practical solutions to translate on organizations' climate ambition into clear, measurable targets and technical approaches. So, Archie is going to look at the early adoption and the performance-driven briefing. So, Archie, I'll let you take the floor.
Thanks a lot, Liz, and hi everyone. I think Sinead covered pretty much everything. I think we should all just get out in the sun and
go home, yeah,
and call it a day. That was very comprehensive, and I think if I was to summarize the presentation that I'm going to give, it would be all of those same comments that Sinead, all those conclusions that Sinead would have made. In particular, starting early and collaboration. It's all about collaboration. And I suppose a deeper level of collaboration, particularly with the clients, with the investors, with the stakeholders at an early stage. So there's a lot of additional work. Now, when I'm asked about the adding services around decarbonisation and around ESG, around sustainability to a project brief, the question usually comes up, well, how do I communicate this to the clients? How do I tell them there's a value add, and how do I actually value my time? And that becomes the challenge. So if there's one thing to take out of this presentation, it's, from my point of view, it's that we need to know that there's an additional need for metrics and data. There's an additional need for close collaboration, not just with the design team, but right up the supply chain, but also with, the likes of Goodbody and KPMG and all of those consultants that actually set the KPIs for a project. So we're going to look at how you embed sustainability. So I'm just going to begin the presentation here. If I can find the little button. But my journey,
yeah.
My journey into sustainability has been kind of a meandering one. I started as an architectural technologist and I studied planning and environment then, and I worked for 8 years in BCAR. And currently I'm working with a Danish-Irish cost consultancy, because in my view, this is all about the numbers, and who better to generate the numbers and quality check the numbers than QSs. But that's on the data side. The best people to run design optimization, optioneering, and all these other tasks that we're going to become familiar with after the end of the day is the architect, because they're good at, looking at the 360-degree horizon. They're also quite skilled in getting together a very diverse set of stakeholders. But they also have an understanding of what the ultimate outcomes are. Things like joy, happiness, quality, daylight, health. So I'm making the case that the leader of the process of decarbonisation and optimization for sustainability is the architects. Okay. So this presentation focuses on the importance of setting measurable performance targets early in the project. So it front ends a bit more work at the start of the project, but it's setting up the project for success. Now, you might look around and see, well, everyone's doing sustainability really well. You know, look at the Nordics, look at the Dutch, look at London, for instance. But they're not. We're all really trying to make it work. There's some leaders, some laggards, but it doesn't work unless the entire industry moves at the same pace, and that we build momentum. Because, you know, after all, if we're looking at changing materials, you know, lower carbon precast, we need every architectural firm, every engineering firm to be saying to tech crews and the like, we need you to have your carbon for those products if we're to use them going forward. Now get us an EPD, get working on your concrete mixtures, and find us solutions that we're going to need, because we're not designing for 2025. The buildings that we have on the drawing board now are going to be transacted in 2030. They're going to be sold and refinanced in 2030. Their tenants are going to be negotiating in 2030. We're designing for 2030 targets. So from now on, the other takeaway, and Sinead has mentioned it, is that we're in a 2030 mindset. But the structure, as Sinead pointed out, the structure of this is we're overlaying sustainability on a process that we're all familiar with, that we all know that works. And we have these 9 stages in our plan of works. And I'm going to focus on the first 4 of those stages. So taking a project from, you know, a mere idea to getting it into a package of information that can be communicated to the contractor. Now, as Sinead said, the later you look at decisions, the higher the impact on cost, on program. So what we're trying to do here is bring decisions that might happen in the developed design, in the tender, or even the tender return, and bring them back into the concept and feasibility. And for a lot of the sustainability KPIs, that's where it needs to happen. If you design for disassembly, you're looking at modular. You need to get in early. If you're looking at aluminium that has high recycled content, well, it takes about 2 years to order hydro aluminium. So starting early is very important. So if we go into those stages, well, what's our initial stage? So we're meeting the client. What do we need to do? So we need to define, well, what do they mean by sustainability? What do they mean by net zero? It's kind of meaningless, but what does it mean for them? And often these clients will have a beautiful brochure that sits on their shelf. That's their sustainability strategy, full of beautiful pictures of buildings in Milan with trees coming out the sides of them, lovely graphs that look like a waterfall that gives them a perfect glide path from high emissions to net zero, just like that, as Tommy Cooper would say. What we want to do is we want them to actually open that up and say, that's lovely, that's really idealistic, but what does that mean for, you know, John the builder, or what does that mean for, you know, Mary the engineer? We need to turn ambition into implementation, and it's a completely different language. The language of ESG, the language of sustainability commitments, all that ambition is just that, it's ambition. But how do we turn that into reality? So we probably have to rewrite the project sustainability brief into a language that makes sense for contractors. And so our early design, we're looking at those targets. Now, there's going to be a lot of back and forth on that, where we're going to kind of test it with the client team, and then we're going to, from the ground up, look at sustainability alternatives. And often what we can do is keep an opportunities register and keep everything, keep 20 or 30 potential initiatives keep tracking them and working out, are they viable? And some will fall off and others will get promoted. So, we're looking at PV. Can we look at mass timber? Can we look at, simple ideas like greener steel procured from Spain or Luxembourg? But a lot of this can be done in the modeling. As we get into scheme design, then we're taking it a little bit deeper. And we're not just looking at energy, we're not just looking at carbon, we're looking at circularity, we're looking at some of the themes that are in the EU taxonomy, which is used for greener finance, for what's called Article 8 or Article 9 green finance. And that brings in things like climate adaptation. How do you deal with summer overheating? And how do you deal with the potential of flooding, compounded flooding effects? And beyond that, then we're into the technical drawings, we're into the clash detection, we're into the very detailed stuff. And that's when it becomes important to actually consider user comfort, user health, but also to try and lock down those opportunities. Are they viable? And it becomes important then to know, what is the metric that you use to say that something is viable? Are you just looking at capital cost, or are you looking at, say, a 7-year horizon? Because the mindset around design is changing from, design a building to hit planning permission and fire cert, get that out for tender, that gets built, and then everyone disappears and starts the process again. Now we're into a life cycle approach. So you'll see that LEED is changing to that life cycle effect, and we're also seeing those other initiatives that are coming in around life cycle thinking, more circular economy, but also monitoring the occupancy and closing the performance gaps. So you'll have heard of Neighbours. And Neighbours is an Australian scheme. They found that no matter how much effort you put into design optimization for energy efficiency, it didn't matter, because what happened was the buildings that were designed as very low energy were very badly managed because they thought they had the job done, where in reality, the buildings that were not designed as low energy needed to put in a very good energy manager. And those buildings, so the buildings that were just LEED certified, were doing much better than the LEED Platinum buildings. So they kind of call that the half fat cake analogy, that because the cake is half the fat, you can have 2 slices. So the overlay, the tasks then continue through all the stages, and there are new tasks that are involved. Some of these tasks are just a line item in a meeting, but others, when you start to look at decarbonizing your external wall buildups, when you start looking at membranes, when you start looking at floor finishes, you can disappear down a rabbit hole and lose a week. How do you recoup your time, your valuable time on that? And that's really where the first task is to show the client what that value is, that the value that you're bringing for sustainability is going to get them a better product, but it's also going to allow them access cheaper finance. It's also going to let them refinance or attract a different type of investor. So, in any transactions now, for be it pension funds or the LDA, one of the key criteria is sustainability, and they will use the themes of the taxonomy or the themes of LEED or the themes of HPI to say, we need your sustainability metrics and they need to be best in class. So we all need to be familiar with what are those KPIs. And so they're the stages post completion, as I mentioned. This is becoming more important, that at the end of a project, when everything is done, you need to find the lessons learned and find out, how do you hand over all that information you've collected at construction to the building operator. So in terms of the stages in our own process, when we start with building a brief, we want to kind of establish what the KPIs or the targets are and kind of test them against the sustainability consultants and test them against the market. The baseline report then is to say, well, if you did nothing different, here's where you're starting. And then we can compare that to the market and say, you know, you talk a good game about sustainability, but your newly developed assets or your retrofits, they really don't stack up against international best practice. They don't even stack up against, you know, Ireland's commitment, say, to the public sector to decarbonize their activities and their assets by 45% by 2030. And then we get into developing strategies. But sometimes you're trying to work on sustainability with very little information. So we put a lot of emphasis on data quality. The other thing we do when we get into the really detailed stuff is we start to use ICMS, and that's becoming mandated now. But what it is the common structure that allows you to report carbon, cost, and program using the same headings, using the same classifications. And we find that really useful because what we want to do is give the contractor templates so they start to measure carbon footprint as the building progresses. And it's a very dynamic thing, but this allows us to streamline and automate it. Sorry, I'm going the wrong way. Be the first time. So if we look at ICMS, what that allows us to do is say, look, let's say we're doing this program of 30 schools. We get into each project and we can say, you know, this is the cost for substructure, this is the carbon for substructure, but we need to go deeper than that. We need to get into the individual elements. So we expand that ICMS structure to go right down to materials and material types. Because when we're decarbonizing a building, let's say we're looking at the concrete, well, below ground might be C30, above ground might be C40. We might have a different type of mix in the downstand beams. We might have precast in the cores. So we need to get into that level of detail. But if we are able to structure this data and we can take Uniclass from BIM or NRM from the bill of quantities, we can tie all of this together and get immediate data. So we can see across all our projects where materials are hotspots and where they can be improved. So someone mentioned to me that the analogy of this, let's say you guys didn't become architects or engineers. So you were sick and you missed the school trip to Paris. You never got to visit the Pompidou Center. And your career went a different way. You became a food scientist. So you're living your best life as a food scientist, and you get called into a 5-star hotel and they say, we have a job for you. We want you to design a low calorie approach for our operations. We want all the food here to be low calorie. So now you got to apply a process. So it's a transition process. So how do you do that? So let's say you never knew anything about building, but you knew about food. How would you do that? What would be the first step? So as I see it, the first step would be to get the managers and the owners in the financial controller, get them in and say, what do you mean by low calorie? Do you mean you're going to, you know, replace the chocolate on the pillows with apple? Or do you mean absolutely every bit of food that's produced in this hotel is going to be half the calorie of what you did before? So, you know, you're replacing the cheeseburgers with pita bread and feta or whatever. So that process is a difficult transition. Now, what's the client going to say to you? The client's going to say, what do I get out of it? If I go to all the trouble of doing all this, will I attract a higher paying customer? Will it add value to my product? And is the juice worth the squeeze? And that's the story that architects are going to have to tell. Is if you invest 2% in a green budget, I can show you how that will manifest as the best money you'll ever spend. And that's the role of the architect in a nutshell. There's lots of numbers, there's lots of additional tasks. But it's about how we tell that story. And that story, to tell that story, it has to be based on data, because in a way, who cares about sustainability? People care about the bottom line, especially the people that are funding projects. They don't give a crap about green. They give a crap about what they really love is greenbacks. So that's the story we have to tell. And underlying that is having good data. It doesn't have to be the most accurate, but it has to be structured and controlled. Okay. So pause for a breath there and get into the more interesting stuff. So we're at the first stage of a project. It's inception. We've been called in. We've a client. They've a big field here and they want to build a community center. And they say, build it green. Off you go. Mrs. Architect, Mr. Engineer, give it your best shot. Here's a brief we have from 2019. It says we want everything green. We want solar panels. We want natural ventilation mixed with MHRV, and we want passive house. Now, take me on a journey. For us, in order to quantify that sustainability, we can all do kind of lovely sketches and pictures about sustainability, but for us, we first have to articulate the value. So costs and carbon for us, they're the two big numbers that we can actually sell that. And it's measurable. It's a bit more difficult to measure biodiversity or climate adaptation, but climate mitigation, we can measure that all day long, because after all, carbon is a currency too. But to do that, we need collaboration, not just people sitting down at a table, but we need the free flow of information between different disciplines and between specialists like the MMC manufacturers and the facade people and our engineering teams. And that's a digital journey. Again. So we talked before about having one language for ESG and finance, and another language then for actually building stuff. Actually, the font is gone here. What this is on the left, it says macro, and this is strategy. And on the right, it says micro, which is implementation. And in the middle is the collaboration. So as the architect, you're at the fulcrum point between the macro, which is the big picture sustainability objectives that organizations have, and then how they actually articulate that in clauses, employer requirements, contractor targets. Yeah, that's your job. So how is that done? And there's some new approaches here. One of them is called optioneering. And that's kind of to systematically evaluate different solutions. So can we go with replacing some of the structure with timber? Can we look at green electric arc or recycled content steel instead of blast furnace steel? And optimization then is another exercise, which is, can we do more with less? Do we really need all this fussy fabric? You know, do we need all this pokey out bits? So it's just minimalism, simplicity, standardization, repeat patterns. You know, so optimization, it can either lead to boring design, or it can lead to a really pared back, simple, modest approach. And then value-based approach is just being able to say, well, if you invest extra capital expenditure, there's a payback to this. Or if you have a greener building, you've greener finance, and there's a balance there, what we call a net present value. And so that kind of triangle, we want to score high on two of those legs of that stool. But we start doing that by setting targets. So we set targets using science-based targets, or using what's often called the CREM, the carbon real estate tool. And RKD and RPS and Hibernia have kind of said, well, we kind of know what good looks like in other countries. We kind of know what the average is. And then we have this thing called our fair share of carbon. So we have a ceiling that we're not allowed to exceed. So we know, like, for 2025, our embodied carbon shouldn't really be higher than around 700. But we also know that that's now. We also know that we're going for 2030 targets. So it should be 550. But that, when you look at a science-based targets, it should be lower. It should be 400. So these are the targets that are kind of set by most countries. There's 2 targets, and they say the yellow dot, you shouldn't be above that for any building. But if you want to say that you're meeting your obligations on your fair share of carbon, then you should be looking at the lower figure. So these are the debates we have, is to kind of calibrate our numbers somewhere between the lower figure and the higher figure. Now, you might say, well, there's no targets in Ireland. There isn't, but these are the targets that apply to all buildings. So every building should know their target. You know, if you're architects and you finish work in Denmark, they often go for a beer because you've public transport and bikes, so you don't have to drive. So it makes sense to go for a beer. And they talk about their buildings and they say, you know, they divide that, say, 500 figure by 50 years. And they'll say, my building is getting a 10. So they'll brag and flex about their carbon footprint of their designs. And that's the way it has to go here. And we can't wait for the EPBD to come in and set methodologies or set targets. Every building should know this target and work to it. And many organizations are doing this. They've set targets and they're trying to meet them and then better them. So for organizations, one of the difficulties we find in this transition process is that people are starting at different starting points. And that's fine. And some organizations that would be very mature in terms of their sustainability messaging, would you leave the boardroom and go into the project delivery room, the organization that looks like they're at a level 3 of maturity and that they're leaders in the industry are actually really at foundation when you trickle down from the C-suite down into the people who do the real work. But this is kind of how we divide it up. So we say, look, green is all about what you buy. It's procurement. It's going back to the hotel. What comes in a truck every morning? You know, that's procurement is the most important. Performance can be a variable. You can start to optimize and improve on that. But then the targets should be clearly understood by everyone. And what we do is we provide a guidance document and a template to the tenders so that they can give that to the contractor and say, put in your numbers and let's see how they compare with the targets that are set. The optioneering exercise is a set of collaborative workshops, but it really allows for innovation and kind of life cycle thinking. But it's a parallel process that happens. So at the start of a project, every designer is allowed to come up with ideas, and then they have a fee which allows them to explore in depth those innovations. And as Sinead said, they'll be focused primarily on embodied carbon and energy efficiency, renewables, but we'll also look at water. And air quality and overheating have become huge issues. We look at waste. And what the client gets out of this is it takes some transition risk out of their investment, but it also means that it protects their reputation because they can back up their sustainability credentials. But it's a different mindset, particularly for the public service, where there's a very strict procurement process. Having an innovation pathway is quite useful to try out new ideas. So how is this done? But it's a challenge. It's complex. It's difficult to do. You know, you can easily get it wrong and be left with egg on your face. There are challenges. You know, the data at the moment isn't great, and there's a lot of silos. Procurement and coordination. You know, you need to get supply chain involved. You need to get the facade people in. You need to get the steelwork suppliers in. You need to get the precast people in. There's a lot of work has to go on early doors with design. What we're seeing with some buildings is they're getting the contractor to come in as a consultant for 6 months or 3 months in an early contractor engagement phase. And this is starting to happen a little bit more now, particularly with developments that are trying to be best in class in terms of sustainability. And that alignment is really about changing mindsets. You know, don't get bogged down in the process of decarbonization or the targets. It's just about sitting down, having a conversation. What does good look like for us? What is the easy wins? Where's the low hanging fruit? Where can we get benefits? Where can we actually start to dip our toe into challenging areas like CLT and mass timber, bio-based materials, things like that. And so we have these workshops, goal setting workshops, integrated design workshops, innovation pathways and opportunities registers, additional tools that we need. But the important bit is the communication, that we have a lexicon or we have a language around sustainability. And we understand that kind of macro and micro view, that we talk to the client in terms of their ESG and their financial controllers requirements for annual non-financial reporting. But we also need to be able to talk about the bricks and mortar. And with life cycle assessment, we can work out where the carbon is hiding. And generally, you know, it's like Bannister Fletcher said, how heavy is your building, Mr. Foster? It's in the big heavy packages, the big volumetric stuff. And we can focus on them initially. We don't have to go down into the brass plates or anything like that. It's the big stuff. So we can focus on, there's generally 5 things that we can focus on, and the rest can get lost. We can look at alternatives. You know, this is a project in Mexico looking at CLT. So what is the carbon saving? You know, how do we work that out? And you see the bar on top is uncertainty. There's a lot of uncertainty within this, but quantity surveyors are good at dealing with uncertainty. So they can have these data. But we can look at, okay, we've got a standard steel building. What happens if we do the columns in mass timber? And what then happens if we do the whole thing in mass timber? And then can we count the timber that's in the forest as well as that, the sequestration? For an apartment block, there's the 2025 target, and this is kind of the optioneering. So precast, concrete, they're all structural concrete and steel, and we're getting a 30% improvement. We're not quite at 2030 targets, but it's a great start. So it's looking at that, and we can price all that. So more AI generated images. So this is the way of looking at that micro and macro. So we break it down into, this is kind of the mindset. We talk strategy, we talk metrics, and then we sell the business case. So we have to first of all say, well, what's your destination? What's your investment horizon? What are you aiming for? And some companies will actually aim for 2040 with their asset developments. We're seeing that in London. And then you have to say, well, how do you do that? Have you got a way of securing funding for that? And then we identify those actions. So are you going to start this year on structure, 2 years' time, envelope, the year after that, M&E? Are you going to set progressively more ambitious? When we get into targets, then we're really trying to calibrate those targets to the financial model. And you know, it's really about just asking questions. You don't have to understand it, but just ask the questions around what are your KPIs for buildings now, and what are they likely to be in 4 years' time when you're cutting the ribbon on that building. And then the business case is kind of balancing up the extra spend with, the medium term benefit. And we do that by setting a carbon price. So the carbon price allows us to test out various options. So it's so I suppose the idea is that transition, sustainability, it's not a singular process. It's really a process. It's really, sorry, it's not a let's start again. It's transition is a mindset, really, and as the architects, you would be expected to lead that process, but backed up with engineers and quantity surveyors that have the metrics. And I think it's about kind of creating a safe environment to say, well, I don't understand what sequestration is. I don't really understand embodied carbon. I mean, I've been doing it for 3 years, and I still think I'm bluffing it. I think you probably agree after this, but it's really about starting the process, and maybe start it with structure. The structural engineers are quite good, and seeing how that improves. But there's a lot of uncertainty. There's a lot of complexity that doesn't need to be here. So take in carbon pricing. For us, carbon pricing is very useful, particularly when you get into the pointy end of a project. We've seen lots of projects that would have 5 or 6 really good sustainability initiatives, but when it actually gets into tender stage, they all drop off as being unviable for program reasons or for cost reasons, and without really the science behind that. So the overlay that you have can be kind of simplified down to just, what are we as a design team providing? What are we providing back to the client? What are we communicating to the contractor? And how do we establish the value within that? So you're seeing a lot of projects now, they're starting to look at embodied carbon. Bord na Móna has a mass timber structure over 5 or 6 floors. And it's designed to be, pretty much net zero building. But the challenge in that is they needed to get the fire engineering and the structural engineering done really early to make that work. They needed to bring in the supply chains, the likes of Rotoblas and Stora Enso from Italy and Germany to look at timber. The facade for timber is a very dynamic material. It's a living material, and so that's a challenge. So once you have that design coordination, you've got to get into the value add. And this is a technique we use, and it's called marginal abatement. Now, we have all our opportunities on the left. And what we're saying here is that we take, say, a 7-year horizon, and we say, if you move from gas to electrification, you're making money after year 7, which is doing really well. But what about the other things? What if you go for fabric improvements to go from Part L to Passive House? There's a certain cost there, but it's marginal. It's easy to sell. HVAC improvements, well, that's always easy to sell. We include carbon offsetting. It's not very credible. It's not very desirable, but it has to be part of the mix if we need to close a gap. It has to be considered. Purchasing renewables, it's a bit of a cheat, but for something like a data center, it's critical. But what we have here is they're getting more expensive and they're getting less impactful. So the width of these is their impact. But what we can say is that there are certain elements here that, even though they're expensive, they're still less than our organization's shadow cost of carbon. So if you fill your car with diesel, you're paying 60 euros a ton of carbon. But the real cost of carbon is closer to 100. And in some cases, as we get to 2030, it's probably over 200. But when we set this carbon price, it allows us to, how my time was, okay, I'll finish up now. If we set this carbon price at, some companies in the UK are up currently at 150 million, it allows us to create a levy or a budget for sustainability. So currently that's only 60 euros. So anything over 60 euros would not be viable. But the higher we raise that internal carbon price, the better. Now that carbon price is something that the client will pay anyway, or to be reflected in the value of a building in the future. So it's de-risking future exposure to stranding or to carbon levies or to just market sentiment. And that's really where, we have to get comfortable with being uncomfortable, trying new things, but we also need to eke out a bit of space to have that sandbox for innovation and sustainability. So how we do that is we have a parallel process, and in the next few seconds, I'm just going to show how we generally see that. So the innovation pathway is where you have kind of you're shunted onto a sidetrack. It might only be 2 or 5% of the overall budget, but if you have ideas that you think are going to be challenging to the client, you separate your project delivery from your discovery. So project delivery is pretty much your linear, get the tender out, get it done with standard procurement. Whereas the innovation is a much more waiting for an animation here, but it's a much more dynamic and fluid approach. So I'll just demonstrate that here using what we call kind of modulating frequencies. Right, press key, there it goes. Okay, so we have our different gateways and we have our standard project approach, but then we have all these other scenarios that we can test. And that's where we can be creative and we can use two mindsets, the fast thinking and the slow thinking. So I'll leave you with that thought that, we have to be innovators, but we also have to be a safe pair of hands. And how we mix those two is very important. Okay, thank you.
So I'm going to introduce John Casey. John Casey is from Cora Consulting Engineers. He's a founder and managing director of Cora Consulting Engineers. John has 30 years experience developing innovative and creative structural engineering solutions for clients across all market sectors. John's approach is to work closely with architects, clients, and industry partners to seek continuous improvement in designs that add real value to the earliest stages of any project. He spearheaded Cora's many award-winning projects and built an organization that works at the highest level of engineering excellence, and in recent years is particularly interested in low embodied carbon design for buildings. He was appointed Irish Green Building Council Life Ambassador in 2024. Quite an achievement. So John, I'm going to let you go forward with some amazing case studies. I've already looked at them, so hopefully people get a lot out of this. All yours, John.
Okay, great. Thanks very much. So I'm following on from Sinéad and Archie, who obviously concern more about the kind of the theory and setting targets and that, and whereas I'm going to be really delivering on the intent, a lot more kind of practical about what we're doing here on this. So I'm trying to turn aspirations of the circular economy into practice. I think we've all seen examples of it over the years, but I really want to show the practicality of it here now. So starting with the RAI 2030 Climate Challenge, Sinéad spoke about this at length, and I'm really concentrating on the first one, reduce embodied carbon by at least 40%. And I think that is the area that myself as a structural engineer can really focus on. And that's why we've been concentrating particularly on that area rather than the operational or reducing water consumption and the likes of that. So just to confirm the kind of areas like Archie and Sinead, we're talking about more kind of stages 1 to 3. I'm really focusing from 3 to 8 here, really, on the work stages, really, you know, from scheme design stage right through detail design and construction. So the first case study that I'm really going to go into in depth is the Treasury building, which we've been working on since 2020. So we're nearly 5 years on it now. It's on site, nearing completion. It was built originally in 1946 as a bakery for Boland's just after the war. It was renovated and extended by Treasury Holdings in 1984, where it was converted into an office building. And Google purchased the building in 2019. And they applied for planning permission in 2020 to renovate and extend the building. And it's currently on site with Shell and Core Works due to complete in July. So we're getting very close. So why I really like concentrating on embodied carbon is you can see here when you look at the different modules for measuring carbon for the whole life of a building, you'll see the modules A1 to A3 take up 50% of the carbon of the building. So it's a huge proportion of it. And out of that 50%, the structural frame of the building will really account for about 70% of that alone. So the structural engineer themselves has a huge part to play in the embodied carbon journey. And if you don't get the frame right and get the embodied carbon to a low level from the very, very start, you really got quite a challenge to get a low embodied carbon building overall and a low life cycle carbon as well. So at the start of the Treasury building project with Google, because it's 5 years ago, we didn't really have that many targets to look at. It was long before people, there was some RIBA targets, some LETI targets from London. LEED and BREEAM were very much focused on kind of operations of a building. There's only about 5% really at that point. We're really talking about embodied carbon. So I was really looking for a target to work with. So I asked Google, would they sign up for this certification, which is a US certification, International Living Future Institute in Washington. And it's called the Zero Carbon Certification, but it concentrates very specifically on embodied carbon. And it effectively says for A1 to A5, you should not exceed 500 kilograms of CO2 equivalent per meter squared. So Google agreed to register with that and certify with that. So that was our target. And that was very, you know, as you know, a voluntary target, but it was very much something to aim for then right from the start. So as Archie was saying, it's really important to have targets set from the outset. I just have to say also, the Treasury building that I'm talking about is a slightly unusual situation because it was an owner occupier. It's not like for a speculative client, a developer who wants to sell it on. So we were dealing with a very flat structure. You know, the decisions that we were making, we were able to get answers on them very quickly, and there was no third parties particularly to ask about it. There's one or two which I'll point out as we go along, but that really helped with everything we were trying to do. So before I really get into the nuts and bolts of what we did in the Treasury building, I just want to point out to you all, because it's a little red document, let's say, our technical guidance document, Part D. It's only about 8 pages long. It hasn't been revised since 2013. And buried in it, there is a couple of little nuggets, and I'll go through a couple of them now. One is the Construction Product Regulations, which talks about CE marking, and it the document, the guidance document says it lays down the conditions for placing or making available on the EU market of construction products by establishing harmonized rules on how to express the performance of construction products for the use of CE marking on those products. So it's just worth, you know, knowing what the definition of CE marking is really about. So it's actually about selling products. That's what it's about, but we all use it for just to know what the quality of the product is there. But it means if you get CE marking, say, for example, from Lithuania, the same product can be sold in Ireland, but we all know that it's reached a certain certification and certain standard, and that's why we use it. But when you go back to the actual definition, that's what the definition is. Also within the document, it talks about existing buildings. And the issue with the existing the clause associated with existing buildings, and this is really important actually, in the case of material alterations or material changes to an existing building, the adoption without modification of the guidance in this document may not in all circumstances be appropriate. In particular, the adherence to guidance, including codes, standards, or technical specifications intended for application in new works may be unduly restrictive or impractical. Buildings of architecture or historical interest are especially likely to give rise to such circumstances. In these situations, alternative approaches based on principles contained in these documents may be more relevant and should be considered. And what we're really referring to there is just the ability to reuse materials. It gives us an opportunity with Part D to do that. And that goes on when we talk about fitness of materials. Fitness of materials, yes, there's a clause there that says everything should be CE marked. That's absolutely fine, or ETA guidance or the likes of that on it. But also there's these sections on, one of them here particularly refers to testing and calculations by an accredited laboratory. Most laboratories wouldn't do the calculations, but they do the testing. So say, for example, we have a project on site at the moment where we want to reuse cast iron beams. And what we're doing is we're getting the quality of the cast iron tested, and then we will do the calculations, and that will prove that it will work and be capable of working without having to take it down. The other one, which is the last one at the bottom there, C, performance in use, that the material can be shown by experience, such as by its use in a substantially similar way in an existing building, to be capable of enabling that building to satisfy the relevant functional requirements of the building regulations. So it's giving us a path to reuse materials all the time. And this is the real bones of the circular economy. It's already written in our guidance documents. If it wasn't written, we'd be lobbying to get it put in there, but it's already there. It's just we don't really know about it because people don't tend to generally go near Part D. So we were aware of all of these ideas in Part D when we set off on our work on the Treasury building, and that's what we put together in working on it. So the Treasury building, this is an image of it from 1986 to 2022. And this is what we're turning it into with a London-based architect, Alfred Hall Monaghan Morris. And we've been, as I was saying, working on it for 5 years. So as we started on it, we were very keen on preserving as much as we could of the building. And if we couldn't, trying to reuse it. One of the first things that when you start talking about trying to reduce the embodied carbon on a building is that it's not about focusing on one area, it's about multiple savings, and it's actually about small savings in those multiple areas. And if you do that, you will actually reduce the overall amount of embodied carbon on the building. So the first thing that a structural engineer should look at, and the reason I'm pointing this out to all you architects, is as design team leaders, you should be asking your conservative structural engineers to look at this, because a lot of them just don't. And they follow the traditional 4+1 imposed loading that has been around since 1991, since the start of the IFSC. Although our Eurocode design loading tells us that we should design in accordance with 3+1. The difficulty we had in Ireland is that no developer wanted to be the first. No one wants to be the first to design a building that has a lower load than the neighbour. And they're afraid or worried, particularly with speculative developments, that they won't get it let. So we set about trying to persuade Google to be the first to change the design of both the existing and the new elements to match the code, Eurocode, one loading, which is 3+1. So after a bit of persuasion, including advice and discussions with their estate agent based in London, who manages the worldwide portfolio, we agreed that we would change it to 3+1. And just to put it in context, and this was the actual slide that clinched it for us when we were presenting to Google, was the fact that we would design multi-story car parks to an imposed load of 2.5+1, so less than an office load. So Google are the first to adopt this really as a client and a building owner. So it was the first part of it. So if you reduce the load on a building, you're going to reduce the burden on the structure. So therefore you can have a lower embodied carbon. Second thing we looked at is the Irish Green Building Council were talking about launching a material exchange website at the time. And the architect tried quite hard to integrate the existing stone cladding that Treasury Holdings had put up on the building in 1984. after a lot of test approaches to it, they found that they couldn't really incorporate it due really to the lack of stone that that was proposed for the building. So what we did is, with the Irish Green Building Council, is that we launched the CMEX website with the stone from the building. So it was advertised for free. It was stored in pallets by the contractor PJ Hegarty. And as of today, so that ended up being 500 square meters of stone in 55 pallets. And as of today, all of that has been taken for reuse by various contractors around the country. We have none of it in our possession anymore. I'm still actually waiting for some nice photographs showing it on buildings, but I haven't managed to get any of those yet because it's gone to such a diverse set of people. But we effectively have managed to get it all for reuse, rather than what was intended for a short while, which was to literally send it to landfill because none of the stone suppliers wanted to get it back. So my advice on this is, if you're planning to renovate, refurbish a building, that you would either look up the CMEX website, or if you're taking stone off or taking materials off that you wish to send for reuse that you can't use yourself, that you do it well in advance. So the mistake we made with the Treasury building is we should have had it up for on the CMEX website long before we even took it off the building, and that gives other architects an opportunity to incorporate it into their designs at that point in that stage. Obviously, we salvaged and reused bricks as much as possible. We were doing a 2-story vertical extension, so any bricks we could get hold of, we were using to match and extend up. All reinforcement bars were being sent in the portion of the building. There was a small 1-story building beside the Treasury building, which we demolished in order to extend, and they were all sent for recycling. One that we brought to the table was the reuse of raised access floor tiles. And this has been a bugbear of ours for quite a while when working on fit out projects, when we would be working for a client just on the fit out, and the landlord would come in and they would take out all the perfectly good raised access floor tiles, throw them in a skip, and then we would have to bring in our own brand new ones. So in discussions with Google, what we agreed is that we would reuse as many raised access floor tiles as we could. So what we decided to do was part of an enabling works contract of stripping out the building, which had many layers built up over the years. What we would do is, it turned out the best way to do it was to clean the raised access floor tiles in place, which is what you see here in the photograph, and in the foreground you can see they still have the layers of glue that are on them. So because the tiles cover all the floors of the building and are a large horizontal element, they actually have a really significant amount of embodied carbon, and they contribute a significant amount to the overall building, like the way a ground floor slab would, or any horizontal slab would as well. So if you can concentrate on those areas, you can save a significant amount of embodied carbon. Speaking to a quantity surveyor, he reckoned that there is between 3 and 4% of the overall embodied carbon of the building is just in the raised access floor tiles. So it's a very significant amount. So those raised access floor tiles were taken up, stored on small pallets for transportation easily. And initially we were going to keep them on site, but it proved too difficult. So those went off site, and these are the tiles coming back to the site and are just starting to be laid again throughout the site. The pedestals are new, so all the old pedestals went for completely recycling. The problem with pedestals is they get damaged as you're trying to take them up, because they tend to be glued down rather than screwed. So it's new pedestals, but the existing tiles are reused completely, and there was no issue with getting a spacer between them. The significant issue with this is there is no manufacturer warranty associated with these tiles. Kingspan wouldn't give one. It's what you see. What we did do is discard any tiles that had any kind of mechanical damage or any holes in them already. But since they were in the possession, they were installed in the building, we knew the provenance of them and where they were. So effectively, everyone was happy to work with them. And just the last point on those tiles, actually, what has happened is we've now moved on to another building where Google are doing a major refurbishment of it. And we have written the specification for the architect, which effectively defines how they are taken up, stored, checked, verified, and any testing that would be required in order before putting them down, in order to provide a technical specification associated with reusing of the tiles. In the UK, there are companies who specialize in coming in, taking the tiles and then certifying them, but that hasn't happened in Ireland as yet. And I understand actually, in order to reduce embodied carbons in building in London, say, for example, a reused tile is more expensive than a new tile in order to reduce the embodied carbon on the building overall. Reuse of aggregates. We tried to reuse aggregates as much as possible on the building. There were certain parts of the building that we were demolishing in order to create the extension, and they were actually really taking out walls in order to create places that people could walk through. So concrete was cut into sections and taken off site. We would have loved to have reused the crushed concrete aggregates within the building itself. Our design codes do permit us to do that, but the EPA has a restriction on that in the certification and the for recycle aggregates going back into buildings at the moment. We've been in discussions with them, but it's still there at the moment. So all our crushed concrete was sent to a company called Greenstone for crushing. So it was reused in civil engineering applications, the likes of roads and various things like that. But it's not permitted to be used in buildings. But I'll mention that again later on. We did try to reduce the embodied carbon of the building. So as I mentioned, that we have two new additional vertical floors on the building, as well as some horizontally as well around the atrium. So we did persuade Google to actually apply for a fire certificate for CLT floors on a steel structure. We knew there was no point in trying to apply with glulam columns and glulam beams as well. It would definitely got a no. Unfortunately, it got rejected and got conditioned out by the fire officer. So we were unable to do this, but Google were willing to push it forward because we went in for a fire cert very early on the project in order to try and get an answer as early as we could. So in the end, what we did is we used a lightweight concrete floor on cellular beams. The idea is the cellular beams are very deep and the surfaces pass through them. So they can be very efficient structurally, and the embodied carbon in them is very low. In the concrete slab itself, I think most people here would be familiar with GGBS, which is a cement replacement product. So what you do is, instead of actually using a full 100% cement in the concrete, what you do is you replace a significant portion of it with GGBS. In Ireland, the average is about 30%. We as a practice have been using 50% as standard for a long time. And in this case, all the horizontal elements on the building were used with 70% GGBS within the concrete slabs. It did upset a couple of contractors tendering for the project, but it was written into the specification at tender stage, so they're well aware of it. It's a big building; they could just stay away from that area for a week after they poured it. In actual fact, the contractor liked it because it said it took a bit longer for the concrete to go off, so he didn't have to be power floating in the middle of the night and annoying the neighbors. He was able to do it the next day, so he was quite happy with it. So one thing that we were particularly keen on is that we knew we were building the vertical and horizontal extensions, so we were trying to figure out what was the best way to do that and the lowest embodied carbon. So this started around 2020. Even before we had the project, we started talking to steel fabricators about where they procured their steel and what their total scrap content was and how that steel was made. And we came across the largest supplier of steel into Ireland, which is a company that has 6 or 7 plants throughout Europe, ArcelorMittal, and they had 2 plants, one in Luxembourg and one in the Basque Country in Spain, where they have nearly 95% scrap content. And it's also an electric arc furnace process. So what we agreed is that we agreed this with the client. We agreed that we would actually specify the plants that the steelwork would come from for the building. So that's what was written into the tender documents, these 2 highlighted areas. And during the tender period, that same company, ArcelorMittal, actually launched a product on the market, which they have called X-Carb, which some people kind of refer to as green steel. Now there's more products coming like this. And when you read the EPD, what you find is that it's exactly those two products that are made in Luxembourg and in the Basque Country that use EAF process, have a very high recycled content, but also they've pushed it even further by having renewable energy source associated with this. So what it has done is it has got the embodied carbon of the actual steel down very low. One of the reasons why it's really good to specify products like this is it sends a message to a manufacturer that when specifiers are specifying products with low embodied carbon, what happens is that the popularity of those brands effectively increase and the ones with the high embodied carbon drop off. So, it sends a message to the manufacturers to shift their kind of manufacturing base to something that is much more environmentally friendly. And a whole other area that we've been working on before we got commissioned to do the Treasury building is the structural steel reuse. It sounds like a very simple and straightforward idea, and I think anyone who grew up in a farming background would be well aware that no farmer ever threw out anything, and they always reused absolutely everything they could, in particular steelwork. The more expensive the product, the more you wanted to reuse it. But in 2019, the Steel Construction Institute in the UK issued a publication known as P427, which was about the structural steel reuse. And to summarize what this document did is this protocol recommends that recertification and refabrication of reclaimed structural steelwork can be CE marked in accordance with BSEN 1090. And that's really, really interesting and important. When the whole document was written, it was to do with that there was thousands of tons of steelwork lying around steel yards in the UK that didn't have any CE marking on it, because it was there from before CE marking was introduced. So this was a protocol to allow that steel to be tested, and then CE marked by the manufacturer. And we took that opportunity of that document because it went into quite a lot of technical aspects of it. And we took that opportunity to see, could we implement that on the Treasury building with the works we were doing. So it was intended to be used for steelwork of unknown provenance. We knew exactly where our steelwork was. We had all the record drawings. We knew everything about that steelwork. It's only supposed to be for post-1970 steelwork, and you wouldn't use steelwork that was involved in bridges or subject to fatigue in it as well. And it's also intended to be used for steelwork that you would say, for example, if you're want to take down a building and replace it with something else, you could take down that steelwork carefully and you could store it in the yard and could be used at a later stage. And that's something that they're doing in the UK, started to do, that they take down a building in one location and use that steelwork in another location. And as I was saying, it provides CE marking in accordance with the British standard that we would use here. Now, referring back to one of the things that I said at the very start, which is about part D of our technical guidance document, when I referred to the construction product regulations, CE marking is required to allow you to sell the steelwork and transition throughout Europe. In our case, what we were going to do was we were going to take down steelwork in one part of the Treasury building and erect it in another part of the Treasury building. So technically we didn't need CE marking in order to do that, but we still decided to progress with the route of P427, which gave us CE marking. And that was really so that we had absolute certainty about the steelwork, and we had it tested and it was CE marked in case building control ever asked us about that. So we just thought it was a very good way of doing it. So one of the things that you'll see here is that we were, I suppose what it is we're not kind of ignoring regulations. What we're trying to do is work to the limit of those regulations and work within them at all cases. And like that the example would be the loading as well. Like we'd never ask Google to not work to code. We worked to the code, but exactly to the code, which was what we all should be doing in order to build buildings that are economical and have a low embodied carbon. So we set about designing the building so we could reuse material. So we modeled both the existing structure and the proposed structure in Revit. We had a whole series of color-coded drawings about what would happen to that steelwork. there's not a huge amount of steelwork that in the end it ended up being 85 tons, which is a significant amount. And we were actually kind of happy with that kind of figure because we didn't actually want to bite off more than we could chew at this stage. And we wanted to use a building that it was worthwhile, but not like 1,000 tons to reuse. We have ideas on that yet, but you know, it was best to start with something small. So what you can see in the foreground is some beams that are light green and up at roof level. So what we did try to do in order to facilitate the contractor, if there was steel that was going to be reused, we would actually take it from lower levels and use it up at roof level and that, so that it wouldn't impact on the program of the contractor. So these are some of our drawings. This is the extension. What's in green and in plan area floor slab will be existing floor slab, and what's grey is the new additional areas that we built on. Just zooming that up, you can see around risers here. If you can see my cursor, you can see the light green elements where it's called up star B60, and then further up here, star B21. They'd all be reused elements. Going back, we have on the table, you may not be able to see it at this size, but on our beam schedule, the green ones are the ones where we would call up steel that is being reused. So around these risers, you can see where steel has been reused. So not a huge percentage, but it's a worthwhile percentage rather than that steel being sent for melting down and recycling. So some examples of how we did it. So you might have seen there, I think a lot of you will be familiar with the atrium there from walking past it for years. This is a photograph from inside the atrium looking up at the roof light. This is it taken down on the ground carefully, the glazing and aluminium coming off, going for recycling. These are the transoms coming down carefully. These are the transoms on the ground. We specifically asked them not to be cut back to the parent material, and that stubs would be left on them, so that they would actually not to damage it, but also to tell the story. What you see on the right-hand side in green, it's literally just after coming down and the guys are inspecting it there, which is the two main columns on the building that were going up the 6 stories that were the main feature columns of the building. They obviously weren't big enough from a architectural point of view because they were clad out with plasterboard after they were erected, and that's why you can see the kind of the channels and the metal furring on it. We came up with a whole structure of how to monitor every piece of steel on the site. So here's a piece of steel on the left that you can see coded. So that coding goes back to a spreadsheet, which I'll show you in a minute. And that's then you can see on the right-hand side the steelwork being loaded straight onto the back of a flatbed truck, which is going directly to the fabricator, so he took possession of it. These are some images of the Revit model, and you can see the green elements are the elements that are reused steelwork. Going back up again. This is actually the steel fabricator's yard, where he has steelwork on the left-hand side there. You can see some nice straight elements with connections on it that came from a mezzanine that was in the building. They were perfect for reuse. And you can see the long green steel columns, which were the main steel columns on the building. We tracked everything with an interactive, actually Google spreadsheet, which allowed both ourselves to define where everything was, as well as putting it on drawings. It had sections in it for the steel fabricator to say when they took possession of it and to put photographs in on it as well, which showed the condition of it when they took possession of it. And then when it got to the factory, that they were able to also track where it went to and what the processes it was and what they did to it. There were some examples like this particular beam that so on the image, it's the same beam, but on the image on the left-hand side, that beam was erected. It used to exist about 2 meters to the right-hand side. So in that case, what the contractor did is he propped the secondary beams, took down the primary beam, sent that primary beam down to the fabricator, had it back within a week up in the same location as before. And then we extended on the secondary beams because they had enough capacity just to extend on the secondary beams. And that process in itself probably saved in the region of two tons of embodied carbon on that beam alone, and it saved a significant amount on the secondary beams. It is worth pointing out at this stage that the cost per ton that the contractor charged our client for that came in the tender rates for reused steel was lower than new steel work. So every time that we actually put in a piece of reused steel, the client saved money than if it was new steel, as well as saving embodied carbon on the project. These are examples of, these were steel channels that were used on the facade in 1984, and this is them down in the fabricator's yard, still with quite a lot of the kind of fixing plates on it from the historic 1986 time. And these are examples of it going back up. The photograph on the left-hand side, you'll see the very light grey steelwork. And if you can think back to where I showed you some risers in light green steelwork, these are steelwork going up the 8 stories here. And you can see the little fixing plates that are still on it here as well. And then on the right-hand side, what you can see here, it's kind of hard to pick out, but those circular columns that had previously gone up 6 stories, what we did is we took them down, we got the plates changed at both ends, they were shot blasted, cleaned and repainted, and sent back to site, and effectively erected 3 stories higher than they previously were located. So they're located on the exact same location, they're just higher up. And what we did is we put in new steel elements, stronger elements with a thicker wall section for the lower floors. So effectively, we took did the steelwork that had been there for 30 years and raised it up to a higher level where it had the capacity to withstand the loads that it had was going to be applied to it. Just to compare the embodied carbon of structural steelwork alone, on the left here you have blast furnace steel. It's 2,520 kilograms of CO2 equivalent per ton. Electric arc furnace steel, which has a very significant amount of scrap content, which is the steelwork fabrication process that is generally used throughout Europe. You may have heard in the UK that they recently closed blast furnace steelwork plants in Port Talbot in Wales, their last ones, and are actually replacing them with EAF steel. So it's important that specifiers do specify EAF steel, because it actually puts pressure on the manufacturers not to continue the old plants, which contribute significantly to global warming. Then the third column over, you'll see X-Carb steel, which is EAF, 100% scrap, and renewable energy is used. And you see that figure at 333 kilograms of CO2 equivalent per ton, which is in the EPD. Now, that figure was a lot lower than we were expecting it to be. I understand it's a lot lower because it's using various carbon accounting rules, which wouldn't actually reflect, and it's kind of spread across a group, and that unfortunately is the ESG requirements allow that, but it doesn't actually reflect exactly what the embodied carbon figure for the steel we used is, but it's in the EPD. That's something more for the accountants and people like the Irish Green Building Council lobbying, trying to get that changed. But it is the best we can do in this market, and it is the steelwork we should be specifying. And then the last one is you compare that to the reused steel, which effectively you're paying for some minor amount of fabrication and transport. And there's been some studies done in the UK on it where they go into great detail to work out how much embodied carbon is used in cutting the end plates off steel beams and that. Well, effectively, it comes out of between 40 and 50 kilograms of CO2 equivalent per ton, which is a massive 98 reduction on the embodied carbon compared to blast furnace steel. So you can see significant savings in terms of embodied carbon associated with steelwork.
Just 1 minute left there, John.
All right. Okay. I got to hurry up a bit. So we were really trying to reduce the embodied carbon by 40%. And our target was 500 kilograms. At the moment, at the last count, we have 207 for stages A1 to A5, and for A to C, we're at 461. And the RAI target is 750, so we're significantly below that. Just to rattle through it, it'll be in the documents you have anyway. We basically saved 3,000 tons of CO2 approximately. Just some photographs of building the building, just to see it. This one looks just like the drawing, thank God. These are the facade going on, a panelized system, the roof going on, and this is it just about at the moment. And just to briefly mention some current projects and our thinking of what we're going through at the moment, the National Library of Ireland, we're working on the West Wing. and the round room. So this is the round room, and one of the things that the project involves is trying to introduce a public gallery in the round room. There is an existing kind of access walkway at the moment. The timber joists aren't sufficient strength in order to take the load of the public, and a glazed canopy that we're trying to put on to keep it soundproof. So the scheme we're coming up with, because we have literally kilometers of shelves that you see here on the left of perfectly good Scots pine timber that was installed 120 years ago. So we're going to take a number of these shelving units and we're going to repurpose them as floor joists and use them to strengthen the existing floor. And that's our detail on the right of what we're going to do. Another project we're working on at the moment, which is the Natural History Museum. And up in the roof space, these are photographs. There's actually 3 sets of trusses in the roof space. There's the original curved ones that when the building was built. About 10 years later, a ley light was introduced, and you can see these quite crude queen post trusses that are installed underneath it. And then on the right-hand side, you can see there's 6 or 7 of the steel trusses that were put in to support the whale structures and the likes of that. We're probably not going to need 2 of them. And what we're immediately thinking of at this stage is that when these trusses come out and we restore the original kind of roof, the question is, what are we going to do with those timbers? But my point is, we're thinking about it right now. We're trying to find a home for how we're going to reuse those materials. Also, there has been a temporary crash deck put in the building. So this is at high level. If you were in the building and you'll see this temporary crash deck with various steel elements in it, we are also going to reuse that steelwork in the building as well. There's no point in throwing it out. The CHQ building we're working on at the moment. I worked on it 20 years ago, longer actually, 25 years ago, where we put in mezzanine structure. We are currently going to repurpose that and create a food market and effectively relocate the steel elements at mezzanine level, but we will be reusing every piece of steelwork and just moving it around the building is what we're going to do. And this is the final one we're working on at the moment, where it just gives you an idea of our way of thinking, where we have been appointed with an architect, Henry J. Lyons, where the idea is that the client said, well, this is the site, guys, we're trying to regenerate the area. It's an industrial building at the moment. I can do a deal with the existing owner to demolish this building and give us an empty site. And I'm saying, no, we actually want the building on the site, and we'll take possession of the building. We'll let an enabling works contractor carefully deconstruct this building, and we'll carefully take the steelwork down, and we'll repurpose it for use in the new building, and we'll try and design the new building around the steelwork. The second thing we're doing there, when I refer back to recycled aggregates and reused aggregates, is that because we can't use them in building projects, what the intention on this particular building is to create quite a lot of landscaped areas, and some of those will be hard landscaped. And what we're intending doing is taking up the ground floor slabs that are in these buildings, which we have to take up anyway, crush them on site, and reuse those aggregates in concrete on the site, because they won't be in building parts of the project. So we will be able to use them in the landscaping, and that's what we're proposing to do. So key takeaways, last slide. Use Part D in the building regulations guidance documents, use it and push it to its limit. Challenge the norm and move beyond compliance. Sinead and Archie are both saying that. And actually implement the circular economy. What you can see, what we're doing in our practice here is we're just bringing this thinking to all our projects. And you guys, as architects and design team members, you should be challenging other members of your design team and asking them to do it. It is very much a collaborative approach, and you'll find a lot of intransigence and people just want to keep with and work with the same old. But it's easy to do once you have the knowledge, and you just need to start thinking about it and actually saying, yes, this can be done, rather than saying, no, let's just throw everything away and start new. Okay, yeah. Thank you very much.
So I'm going to move along to Edel before we do questions. So it'll be Q&A session afterwards for yourself and Edel. So I'll introduce Edel Collins. She's assistant principal architect at the Office of Public Works, where she's registered architect and head of major projects with responsibilities for a wide variety of new build and conservation projects. So she completed projects that have been published in Europe, China, and Japan. Citations include Irish Annual Architectural Construction Awards and Landscape Award. She has professional project management qualification and represents the OPW on cross-government and CIF boards. Edel is a member of the RIAI Board of Architectural Education and has lectured extensively on public procurement, including the RIAI Professional Practice Examination course. Quite a repertoire. So I'm going to let you take over, Edel, if that's okay.
That's great. Thank you very much, Elizabeth.
Lovely.
And good afternoon, everyone. I'm going to just very briefly give an introduction on post-occupancy evaluation. And then I'm going to use a project as a case study to just describe how we took project objectives, evaluated them, and then feed them into future projects. I suppose what's already been mentioned earlier in the presentations, that it's an iterative process. And I think hopefully you'll see that I'll demonstrate throughout this presentation how lessons learned from one project will feed into the strategic decisions of future projects, but also that you can't actually do post-occupancy studies or unless you actually have a clear outcome from the beginning. So post-occupancy evaluations, I suppose what it really is to demonstrate how I suppose you're asking really 4 questions, and you're asking yourself, is the building performing as it should? And if it isn't, you're trying to find out why. And then from that learning knowledge is feeding into other projects. I suppose I see it building on existing structures and processes that we already have in the public sector, including the infrastructure guidelines, where we have to do project completion reports and ex post evaluations. I suppose we're in this kind of transition space at the moment, and we're finding that we've had to apply different approaches in respect to post-occupancy evaluation on projects that we're currently active in the office. And that's because the lead-in time for projects or the project life cycle is quite long. And so some projects where we're just going out for consultants, it's fine, we can incorporate the scope of post-occupancy evaluation and all that's required throughout the project life cycle in the scope of services for consultants. However, projects that are nearing completion or just very recently completed, we've had to extend the scope of services. And on other projects we've taken where projects maybe that are completed 3 or 4 years, where we are actually now procuring separately occupancy evaluation to see, is the building really performing as we had designed it a number of years ago. So the case study I'm going to bring you through today is the Tom Johnson House, which was refurbished as a new headquarters building for the Department of Environment, Climate and Communications. And we were very fortunate that they were the client for this department because they were definitely a key project champion to push the agenda to achieve all of our objectives from the beginning. The project is a deep retrofit of a typical 1970s building. It's 5 stories over basement, and there's an aerial view of it, and you can see that it's in a historic military fort, which was a protected structure. And for the deep retrofit, what we did was we upgraded the external facade and the roof. We stripped out all the internal finishes and replaced them. And we also provided new installation of mechanical and electrical services. I suppose before we can actually talk about the evaluation studies, we actually have to be kind of clear what the project objective was. So for this project, it was to consolidate staff that were in multiple buildings and that were in very poor performing buildings. And we also wanted them to move from leased to owned accommodation. The department wanted it to be a flagship building as well. And I suppose things we were considering when we were looking at these project objectives and throughout the process was actually the pyramid approach. So these are some of the key targets that we would have looked at the early stage of the project. And I think they're very obvious. It was to increase building capacity, to upgrade the building to an NCEP to achieve an A2 BER, to reduce the operational energy, And I suppose in addition as well, support staff health and well-being. And then a target that came in later on in the project was just before we actually placed our contract, was in respect to the waste. And that was because the project, in the end, just before we placed the contract, was getting funding from Europe. And there was particular requirements that we had to meet to get that funding from Europe. So that became kind of a more focused target than it had been earlier on in the project. I'm just including this slide just to, I suppose, demonstrate that a kind of a key, one of the first considerations that the OPW has when we're undertaking this type of project is that we actually look at the building's capacity. And I suppose it's similar to a point that Sinead was making earlier, is to actually understand how it really is working. So we take regular surveys of our estate, and you can see from the results of this survey of, and these are offices in the Dublin area, that more than half of the workstations provided were unoccupied. And then in addition, we look at the we've identified through basic space planning the potential for additional workstations. So I suppose this is a really easy way we see of achieving a greater capacity with no embodied carbon. So for this project, at the outset, we wanted to increase the building capacity from 200 workstations to nearly 500. You can see that's an increase of 146%. I've included a plan of the building before the refurbishment, and you can see that it was very cellular with long corridors and with very little natural daylight into the internal core area. But how we approached the reorganisation of the space was to open up into open plan offices, but that were subdivided by grouping together meeting rooms and offices, so that you could form little communities. It also helps, I suppose, from a staff well-being perspective, so that it doesn't feel like a call centre, and also acoustically, it's a much nicer environment. Also, we have been monitoring since the client, we've completed the building at the end of 2023, and the client, the building was fully occupied by mid-2024. The average occupancy, you can see, is not their full staff numbers, and it's not meeting the number of workstations we have, but it has a significantly increased since the 2019 levels, but it also demonstrates that there is that the building can accommodate further staff numbers for the department. And I suppose that's one of the benefits of having a BMS system, access control, and that we can actually monitor these kind of occupancy levels. Another element that we put a lot of effort in early in the project was to get the optimum ratio of cellular offices to open plan offices, and to meeting rooms, and then of support spaces. Because experience from other projects was that if you don't get the proportion of that right, the open plan space doesn't work. We're also coming from, I suppose, a situation where there was an expectation within the civil service that certain grades were get a room, so what we were also doing is we had to manage that to actually accommodate the greater capacities that I had illustrated on the page before. Some key lessons to take from this project was that the booking system that was installed for this project, so that's the booking of all of the cellular offices, of the meeting rooms, and of each of the workstations, allowed that people weren't able to claim ownership of a table. The other key enabler to people not owning a workstation or an office is that you have to provide sufficient lockers. So we at the time had provided as part of the construction project 500 lockers to match the number of workstations, but actually since then we've had to install another 100 lockers because to match the actual staff numbers within the department. I suppose the other key element of building capacity is that there is behavioural changes, and that's in respect to the whole change management process. For example, the department, as we started the construction project, they started a digitalisation process, a data management, new protocols and strategy. And I suppose during the project as well, we had COVID. So that did bring in blended working and I suppose a greater acceptance of hot desks. So I suppose one of the key things that we had to look at was how to reduce carbon. We looked at all the different options available to us. So we looked at, do we demolish the building? Do we do a light retrofit or a deep retrofit? The building was at end of life, and so we did have to do a deep retrofit. But we were fortunate enough that we were able to find original drawings and details of the construction of the building. And we were able to carry out studies which demonstrated that the structure was fit for purpose. So we were able to keep the existing concrete structure, including the stair cores and the external walls and brick facade. And this move alone, or this key decision, allowed or means it reduced significantly the embodied carbon, as in it's 51% less than if we had built a new building. Materials. We were very fortunate that during the process that we had the client's support in the assessment of materials. And as I mentioned, they were a kind of a real champion of this project, and the actual staff members were very aligned with the whole project. So we would have had, as part of staff engagement, and they wanted to know exactly what materials we were being installed on the project. And they actually wanted to know what the level of their recycled content is. But they would have also, which was of a huge benefit to us, that helped us do the assessment of the materials, because it was, I suppose, a new space for us. And it is very important to get all of the expertise that you need to help you make the decisions at the right time. And I suppose one thing though is that particularly during the construction stage, when the materials, because during the process, like it is a full year by the time you go out to tender before the contractor starts on site, and the materials have changed and there's better products out there. So again, to have had that access to that expertise was a huge benefit to the project. This is we undertook an embodied carbon analysis and assessment at the end of last year, and I'm just including some extracts of it because I found it quite surprising that actually site works were greater than the M&E in respect to embodied carbon. And when we looked a little bit deeper at that, the key driver of that was the stone materials. I suppose also just what we have learned is one of the key lessons that came out from that analysis was that if we had changed the metal framing partition to just a different system, we would have been able to reduce the embodied carbon of that element by nearly 3/4. And I suppose we've found out so we've taken that knowledge and fed it into other refurbishment projects we're doing at the moment. And even on those projects now, we're learning that the raised access floor that we were proposing in that project, by simply changing it to a different product, we're reducing the embodied carbon by 55%. So I think this embodied carbon analysis and assessment is a really useful tool to help focus on what areas can you get those quick wins from reducing embodied carbon. As one thing that's really important for us is that we build in flexibility for future needs, because we have the buildings and we'll have them for the next 80, 100 years. So for example, an example of this would be that externally we would have provided ducting throughout the whole car parking and for EV charging. So in respect to the operational energy, a key target that we had from the outside was that we were going to take the building from a C3 to an A2. Now we did consider, should we be going to an A1? And we could have achieved it, but to achieve it, we would have had to take out the lower ground floor and put in insulation and put back a new concrete floor. And the impact, the embodied carbon impact of that, we didn't think justified doing it just to be able to say that we had achieved an A1. So I do think a little bit of judgment needs to come in as well on looking at it holistically. So to achieve that A2, you are not going to be surprised to see that air tightness was a key feature of that. That was particularly, well, the contractor was very concerned about being able to achieve that. We had it clearly stated in our work requirements, and we would have worked closely with him on site to achieve it. I suppose what we did was first in place, and because it was a repeatable element, we did that actually very early on in the process, so that we were all so it was tested and verified, and then he could actually go on and replicate that throughout the project. It was really beneficial, the inputs from a special consultant that we got in as part of that consideration. The other, to achieve the A2, we also upgraded the building envelope, and in particular in respect to insulation on the inside, and where we installed recycled glazed bead installation. I've just listed a number of the analysis that we would have undertaken as part of the studies to inform design decisions and material choice. And I suppose it's really important that you get these studies done as early as you can to inform those key initial decisions, and then actually that you continue to get them done to test that what your intended solution is actually achieving the results that you want. I suppose just a lesson we learned from this project was the ESB substation is actually within the footprint of the building, and we hadn't clearly identified where that thermal line and the air tightness line was in respect to that. And that was something that caused some confusion during the construction stage. So I suppose that's just those type of spaces. It's worth just making sure that they're clearly delineated as part of the exercise. As you can imagine, high performing glazing ties in with the high performance envelope, I suppose a key thing in respect to the glazing is that we wanted, as well as to maximise the natural daylighting, we wanted to maximise the natural ventilation. And so what we have done is the windows are connected to the BMS system. We have them also connected to the CO2 sensors and temperature sensors in the room. They're at 3 different settings, so that depending on the CO2 level or the temperature, that the window will open at particular degrees. Now, I suppose the important lesson learned, and that's been very successful as a strategy in managing the ventilation and the temperatures within the room. I suppose staff also have local control, but it has been a bit of an irritant to the staff, because there has been a kind of a process to fine tune that. So where the window would be opening and closing and opening and closing, because basically the settings on the BMS, they were too sensitive. So we've had to adjust that. And that's something that I think when you have a natural ventilation solution tied in with a BMS system, it does take nearly a full year cycle, because you need to kind of get through all of the different weather events. And I suppose one of the key things how we came over the problem was we reduced the CO2 sensor is now not overtaking the temperature sensor. So we're letting the temperature sensor be the dominant sensor between the two of them. I suppose the biggest key intervention we did on the building was the introduction of an atrium into the middle of the floor plan. And again, that was to facilitate daylight and ventilation. It also, the space acts allows smoke extract. And we designed the balconies that they could also provide social spaces and collaboration. I suppose I feel very fortunate that I work in the OPW, and it's a multidisciplinary organisation where we have mechanical and electrical engineers who not only involved in the design of projects, but are also involved in the maintenance of over 200 buildings. And with that, they bring particular knowledge and expertise. They have also developed up from one project to another specification. And they insist that we will always go for a reserve specialist, because for us, it's very important that we get the plant and equipment and the installation to the right specification and to the right standard. For this building, it's a fossil-free building, which is the first one OPW had done. We achieved that through 2 very large multifunction air source heat pumps and 112 PV panels. And I suppose what we had, this is where I suppose an example of where our client, I suppose, championed the idea of the fossil-free right down to the nth degree, was in respect to the backup generator. So they, I suppose, pushed OPW for the first time to install a hydrated vegetable oil backup generator. So as I mentioned, the building was a full strip out of the mechanical and electrical services. And then we, again, put back in tried and tested lighting that's intelligent, that responds to time, presence and absence presence. I suppose one other thing that we learned, I suppose, in respect to equipment is the white goods. So when we went out to tender, at the time we put in the most energy efficient white goods we could. By, as you can imagine, 2.5, 3 years later, when the white goods were actually ready to be purchased by the contractor and installed, they were actually no longer even available. So there is always a challenge that you need to allow some sort of capacity within your works requirements, knowing that certain things are actually going to be continuously improving during a period, so that you can manage the costs and the impacts of that on the project. A key aim from us from the beginning was to reduce water consumption. And I suppose one area that we are looking at more is, as well as just like obviously for the water consumption, we have installed low flow fixtures, but I think there is an opportunity for us to put in more sub-metering, so that we can actually analyse exactly what water is being used where, and is it all as per the design intent. So I think I mentioned the BMS, the building management system, a number of times, and I suppose that's a key element for this type of building. It allows the building to act as an intelligent building, and it's something that the buildings are getting more and more intelligent, and the systems are getting more and more complicated. And I suppose that's one thing that we've actually, like on this project and on other projects that are recently completed, the level of coordination and engagement between the different consultants to fully coordinate and specify the requirements in the BMS system is an area of where we're going to be putting a lot more effort, because it is an area where the documents are not fully comprehensive and going out to tender, and then the gaps that appear during the construction stage, which leads to confusion and changes. In OPW, any of our new buildings, we also install an energy monitoring system, and we do that because obviously the BMS system can store data that can be reviewed and analysed. But OPW, we have installed, because we have a portfolio of over 300 buildings where we have building management systems fully functioning, and we use this dedicated system to capture all of that information. I suppose the advantage of that is that it's quite structured, and it allows us to do checks twice a year to make sure that everything's performing as it should. And it also allows centrally OPW to adjust systems, for example, the summer heating. So you're not reliant on individuals to change the settings required as the seasons go through the year. This is just, I suppose, the data from the energy usage, and you can see that it has a reduction of 75%. The display energy certificate for Tom Johnson House is being developed at the moment. We wait typically for a full year's occupation, because we don't want to do one where you get a lower reading and then the next year you actually have a higher one. So we think it's better to start off with what it is at that point. In OPW, we have found that the display energy certificate is hugely positive in encouraging positive operational use of a building. I suppose it's because it's prominently displayed, it motivates people to seek improvements year on year out. I've just included a graph from Optimizing Power at Work program, which is run by our M&E section in OPW, which was initiated in 2010. But I think when you look at it, you can see very clearly how the buildings have gone from the low ratings and moving up into the B space. And what's very interesting is, so like now we have more than 75% of our buildings are at a C, SSC. But with behaviour alone, what OPW would have noticed that over the first 5 years, with no investment, there was an 20% improvement on the energy, operational energy. And then only with light interventions, another 15% improvement was achieved, which gives like a third of an improvement on operational energy with very low investment. So it really is an area that should be, the value of it does need to be, I suppose, described to the client. Another aspect from the beginning of the project was obviously the staff health and well-being, and I think you can see from the early plan that the building wasn't a happy building before. It was very dark and with the natural ventilation didn't work very well. And I suppose what we have done as well is where there wasn't an external space, but there was actually no connectivity between the building and it. And so one of the other actions we did was to open up the building to it, to achieve staff and health well-being. And so to date, the feedback from staff has been very positive, but we will be undertaking a formal survey with them in respect to the valuation. As I mentioned, waste then became a kind of a real focus during the construction stage because of the funding element. And the European requirement was that we had to recycle a minimum of 90%. We were able to achieve 90.66%. And because this was being funded by Europe, it was really, really important that we had full evidence of it. So what we ended up doing is, as well as it being included in the work requirements and the contractor having to demonstrate monthly reports of how the waste was being treated, we also actually took on an independent external consultant who actually verified that. And that, I suppose, gave us comfort that we were going to meet that threshold that required by Europe. So I suppose just to conclude, some key takeaways is that it's really important that you need to know what your goals are if you want to be at the very beginning of the project, so that you know how to be able to collect them, or that you'll be able to collect them at the end. It's really important to be able to engage people, the right people, as early as possible to help inform those decisions. The process is a learning opportunity, and it's definitely iterative. Anything that's working, that's tried and tested, it's really important just to build on that. And hopefully I've demonstrated the importance of the feedback loop. Thank you very much.